Right. So having taken a look at the mechanisms by which we convert class diagrams to relational schemas, what are how do we measure whether the model is good, right? That it represents a reality, right? So first of all, it all starts with requirements, right? This is the most crucial part that errors in the gathering of requirements are the most hardest to fix later on, right? And this is where most of the errors occur, right? In requirements gathering phase, and we have to make a lot of effort at fixing it as early as possible, right? The later these bad requirements make it into our design, the harder and more expensive it is to fix later on, right? So certainly it is the most vulnerable moment of any project, right? Gathering those requirements. So definitely, but it's the most important part of this. So the second one, the second step is that from these requirements, you come up with lots of nouns and verbs and that specify the data that you're collecting. What's the structure? What's the relationship between these? And especially if you're not familiar with the domain knowledge, right? Then for you, any noun is important, okay? And as far as you're concerned, every noun is a class. And you don't know if certain nouns are just part of some other noun, right? Just because of your lack of knowledge in that particular domain. As you gather more understanding of the domain, you might start considering that not everything is a class. Some things might be just attributes that describe some other class, right? Or things that you thought were attributes actually should be represented as classes. Okay, so you'll come up with a preliminary class diagram that by all means it'll have lots and lots of mistakes, right? And more requirements gathering, more discussion with the business will help you refine what the actual class diagram will be. You'll also come up with inadequate relationships, right? That you either it might be because you were thinking relationships between two distinct nouns, but there might be many nouns that are participating in the same relationship. Okay, so perhaps some of the relationship are missing some additional relationship in there. You might also have some redundant relationships where you could answer the same query by following any number of paths, alternative paths, and which might be a problem, right? Because again, remember that redundant information breeds inconsistency, right? And we want to make sure that the data is only captured in one particular way. It can be answered only one particular way. Also, we need to take a look at the weak and strong relationship, for which our algorithm, our earlier algorithm, does not handle. Right? We need to deal with those as well. And finally, identify, revisit this, whether classes should have been attributes or attributes should have been classes. And there might be several iterations of this over and over as you discuss this with the folks, the stakeholders, and the business owners and the users are using this. The more you understand the domain of that particular project. So lots of interviews at first, lots of discussion and people voting and having they themselves argue amongst themselves on what actually means certain things means in their business and how they're related to one another and what their priorities are. A lot of dealing with people. It's very messy. You have folks that study this and do this for a living. Business analysts. They're a typical breed of folks that have these kind of people skills. I don't have them, certainly. And some folks like to do this, right? Deal with these long interviews and socializing and capturing, dealing with inconsistencies and dealing with contradictions and dealing with a lot of hidden agendas and extract what really the business is, right? Anyway, data entry forms that they're filling out, what kind of queries they want to do on the system, what kind of reports do they want to generate, and they generate a requirement specification at a point. So here's what an example requirement spec might be from interviews that we might have had with our client, and so this might be a preliminary discussion or capturing of what the problem statement might be, right? So we are at a university. It's composed of departments. Academic departments such as mathematics and drama departments are responsible for offering courses. Non-academic departments such as admissions and dining hall departments are responsible for other tasks that keep the university running. Completely irrelevant information. Each student in the university has a graduation year and majors in a particular department. Each year, the user who have not yet graduated enroll in 0 or more courses. A course may not be offered in a given year, but if it is offered, it can have 1 or more sections, each of which is taught by a professor. A student enrolls in a particular section of each desired course. Each student is allowed to have 1 car on campus. In order to park on campus, the student must request a parking permit from the campus security department. To avoid misuse, a parking permit lists the license plate and model of the car. So that might be the original problem statement as interviewed by one of the stakeholders. Okay, and it might be that things that are fairly important to this person might be irrelevant to someone else, right? And so it's very important to meet with as wide an audience as possible, right? And get a lot of perspective, especially the folks who are going to end up using your software. Okay, you have a good representation of the folks that are going to be using this. Some other requirements. The database should allow students to declare and change major departments, keep track of parking permits, allow departments at the beginning of the year to specify how many sections of a course it will offer and who will teach each section, allows current students to enroll in section each year, allow professors to assign grades to students in their section. And every time you see a noun here or a verb, right, it's important that you catalog this, right? You create a dictionary, a data dictionary of all these verbs, all these nouns, and how they're related to one another, because they're going to give you clues, right, of what the structure is, right? What is an attribute of some other class, or whether an attribute is actually a class, right? So here's a preliminary catalog of the various nouns, the various verbs, and how they might relate certain nouns to certain other nouns, right? So a student receives grades, professor assigns grades, professor teaches sections offered in year, student requests permit. So all these nouns and all these verbs, right, give you a clue on what the structure of the data is, right? Some of these might be completely irrelevant, right? Nonetheless, we jot them down, and some of these might be mistakes, right? Where if we might have oversimplified this, and a relationship, instead of being between 2 nouns, it's actually between 3 nouns, right? Later on we'll come back to this, and it'll say, a student, a professor assigns a grade, right? But actually, if we read it a little more carefully, it actually, I think it read something like, a professor assigns a grade for a section, right? So there's actually 3 nouns associated in there, right, as opposed to just 2, right? That's gonna lead us later on into an inadequate relationship, right? Some relation that is not actually capturing correctly because it doesn't have enough information. So first of all, we're gonna have to start throwing away some nouns here that are irrelevant to our particular scope. Okay. For instance, one of the things that are, even though the database is for a university, the noun university here is irrelevant. Right? There's nothing that we're capturing about the university itself. Okay? If this were the Department of Education,
transportation.
Is there a Department of Education?
The college within the university, then you'd need it.
Well, I meant government agencies, right? So if there were a Department of Education that was keeping track of all the universities, right, in the state, then maybe we do want to keep track of a list of universities. But in this particular scope, we're not keeping track of information about many universities, right? So we don't need a list of universities. This is just one, yes? So we don't need a class, right, to keep track of many instances of universities. There's only one. So there's no need for us to track any information about the university, right? Yes?
In one of the previous iterations of this, you had one course that was like, I think it was Brando teaching a movies class versus someone doing a calculus class.
Right.
Now, one would be College of Arts, Media, and Design.
Right.
One would be College of Arts and Science. Would that be a reason to keep university?
Well, maybe not university, maybe the college.
Okay.
Right. So yes, we might have a list of colleges. Then yes.
Colleges have departments.
Yes.
And then you could link them out.
Exactly. Yep. Yes. Right. So in our scope, right, we don't need to keep track of the university. Maybe colleges, perhaps, and also you might want to start deciding on about that car that we're keeping track of. Are we? How much do we need to know about a car, right? If you're Ford, maybe you want to know a lot about a car, right? And all the different pieces that make up a car and how they're put together and who provides all these parts, the seller, the provider, and whatnot. For us to be able to model a car, maybe it's enough to know the color, the year, the make, and that's it, right? That's enough for us. Does those three attributes fully describe a car? No. In our scope, it does. Right? And that's what we mean to model, right? Is to gather enough information to create an abstraction of something that represents reality, right? And usually we prefer these abstractions and remove any of the unnecessary details, right? That are not needed in our particular modeling. Make sense? Right? So for instance, one of the things that you might consider, for instance, if you look at the map in Google Maps, right, and you see the satellite version of this, and then you see the map version of it, right, where you don't have the greenery and the blue and everything, and the map version is just an abstraction of the reality, right? It might render a lake just by a little blue oval, right? And maybe that's just enough at the level of scope that we want to understand. Where we just want to see, traffic, and we want to see roads and whatnot, right? That level of abstraction is enough. We don't need to go further and into that detail. So modeling goes as far as what it is that you want to be able to answer, right? What information do you want to be able to abstract? Scope. We need to understand what scope is a university. What scope do we want to know about the car? Some things are completely irrelevant. Right, the non-academic department, we don't need to capture that. There's nothing but we're asking about them. It's composed of, it's requests. None of those are irrelevant. I'm sorry, all those are irrelevant. So you might come up with something like this, right? Like a preliminary class diagram where you have, certainly we see some of the where we're going, right? Notice that we have a department. There's only one department, many students. Here we have some phrases that we might read from the original diagrams. We have that students receives a grade, professor assigns a grade, a student enrolls in a section, a professor teaches a section. So it looks like this is capturing, right, all those nouns and verbs relations that we saw earlier, and we might come up with something like this initially. Then we need to start iterating over this, right? Looking for, as we reread the specifications, as we re-interview our users, as we present this to our client, right? Whether this is capturing the necessary information, we might find that this doesn't quite cut it, right? There's some things that this is not capturing, right? So let's look at some of the inadequate relationships and why we might have created them in the first place. Okay. So from the student record, we have the following relationships, right? We have the student majors in, right, allows us to navigate to the department. right? The enrolls in allows us to navigate to the section. Enrolls in and has, allows us to navigate to the course instances, right? So from student, we can go to majors, receives, enrolls, allows you to navigate to everybody else, right? But notice that we could have instead of saying that students enrolls in section and course has a section, we could have decided this alternative way to go, right? Student enrolls in course, right, as opposed to section, right? This would have been, this would make sense, right? I am enrolling in a course. Yeah, that makes sense, right? I'm enrolling in a course. And then go up further and say that course has section. This could have been an alternative representation of the way we read it, right? Now this one is inadequate because this doesn't allow us to answer some of the fundamental questions, right? If I give you a student, I like to be able to answer what section are you in, right? When my schedule comes up at the beginning of the semester, I like to see, I'm in section 1, 2, or 3, right? This data representative does not allow you to capture any of that, right? It tells you that you are, there's a many-to-many in the course, but it doesn't tell you, right, specifically what section you're in. It tells you that there's a whole bunch of sections for a course, but notice that there's no relationship between the section and the student. You see that? It only goes as far as saying you are in this course, but I can't tell you which section it is. It does not capture that. See that? That's why we could have, as we were reading it, perhaps we would have said, oh, wait, no, you don't enroll in a course. You enroll in a section, not in a course, right? But this might have been a mistake we would have made, right? And you see that it's an inadequate relationship, right? It was not capturing, it was not able to answer the question what section you're in, and what's one of the fundamental questions that we are asking. Right. So we have to make sure that that it answers the question that the queries that we're making, and usually we need to be able to answer those questions by exhaustively going through every single path, right, and see that it has the information that we need. Let's look at a couple more. So receives captures grade for each student, but not section. So this receives over here, it says a student receives a grade. Okay, but then for what, right? So we can say, yeah, the student has a grade, but it doesn't say for which course it was, which section it was, right? And also says that a professor assigns the grade, right? Assigns gave but no student. So there's it doesn't tell you, right? Assigns the grade. It doesn't say for which section was this in, right? When the student was enrolled in a particular section, right? There is no relation that captures all these three things, right? So the reason we might have painted ourselves into this problem is that we oversimplified when we were reading through this, right? For instance, we only read as far as saying that a particular student receives a grade, right? But we should have read a little further, it said something like student receives a grade for enrolled in a particular section, right? So we now realize that, wait a minute, it's not just those two nouns that were in the relationship. There were three nouns in that relationship, right? And also here we have another one. A professor assigns a grade. We should have read a little further, and we would have realized that actually there's three things participating here, right? Professor assigns a grade to students in their sections, right? So there's grades, professors, students, and sections that are participating in that relationship, right? So we need to see how we go about fixing these inadequate relationships, right? So if there's more than two nouns, we have to be careful, right? We have to look for these things. So in this one over here, student receives grades, especially if we have a many-to-many, right? That's kind of a clue, right? That perhaps we need a little more information about this relationship. Okay. So let's look at this one. Student receives grade. We want to be able to capture those three relationships. Right? The receives verb here is relating three things: the student, the section, and the grade. Right? Not just a student and a grade, but those three things. Right? And the way that we can capture that relationship is to reify. Right? Reify is the act of making something concrete. Right? This receives a verb here is a little bit vague, right? Of how is it that you're going to capture this, right? We can make it concrete by substituting the receives node there, right? The vague receives node by a more concrete entity here or class that keeps track of the relationship between all these three things, right? Where you have foreign keys, right, that go off from the grade assignment. They go off to each one of them, the student, the section, and the grade. So a particular record, right, particular record in this grade assignment is pointing that that student over there, right, received this grade in that section over there, right? And so it's relating those three things, right, that live in separate classes themselves. Make sense? All right, so those are all foreign keys pointing to primary keys on each one of these. Okay. So yeah, so the one. There's only one grade, and that's just a unique values, A minus, B plus, B minus. So those are all unique primary keys. And then the stars say that there are several students and several sections that participate in each one of these relationships. Okay. Yeah, grade assignment. Right, this eventually, right, is going to become the enrollment table that we saw earlier, right? That is going to, since there's only one grade participating here, we can bring that into the grade assignment and make it into the enrollment table that we introduced earlier in the lecture. So yeah, so reification is the act of making something that is vague or very high level, right, implementing in something that is concrete, right? Like for instance, that single receives verb, right? We convert it into a concrete table, right? That then has references to all the other entities in the other tables, right? So we can now convert our initial class diagram and create a relationship between the grade, the section, and the student that were originally spread apart, and we couldn't tell what grade you got for a particular section for a particular student, and we're going to substitute. We're going to substitute this the relationship between these three here: the student, the section, and the grade, and we're going to substitute it by a grade assignment that relates a grade to a section to a student. Okay. Right after reifying it. Now, some relationships are going to be redundant in that if you traverse the foreign keys and primary keys and navigate from one class to the next to the next to the next, you're able to answer certain questions that you could answer it if you follow yet another path, right? And that's fine in the problem up until you realize that. When you start adding information here, some of the information is going to be redundant, right? It's going to be, and we always been making sure to try and avoid this because of the risk of inconsistency, right? That if there's two ways to query it, well, there might be also two ways to update it, right? It might be that we remember to update it one way, but we don't remember to update it the second way, right? And eventually, data will start to drift apart, right? And you'll have one version, and then you might have another version, right? And then at some point, you're gonna ask yourself, well, which one do I believe? Do I believe this first version or the second version? So it just reduces the value of the overall data that you are capturing. So definitely we want to reduce or eliminate redundancy from our data model. Here we have the student, we have the grade assignments, from earlier. I think this is a slide that should have been earlier from the previous. Oh no, okay, redundant relationships. Okay, so we have students, we have grade assignments that are referencing the students, and we have pointing to sections. So we have student ID. All right, so this we have 3 assignments, 2 different sections here, pointing to section 1 over here. And they're also enrolled in other sections here, 2 and 3, and pointing to the course. Okay. All right. That's just capturing the relationship and an example of the data set for each one of these. So anyway, so we could notice that we can navigate and answer the questions about what grade did you get for a particular section, and what grade did the professor assign. Notice that we can traverse it either navigating to the right-hand side, right, or navigating from the left-hand side and go back to the professor. So this assigns relationship on the right-hand side is kind of redundant because I already can navigate it going on the left-hand side, right? I can follow the foreign keys from the grade assignment to the section, and from the section I can follow the foreign key back to the professor. So I can answer, right, what grade was assigned in what section by which professor, right? I can also, I could also answer the same question if I follow the assigns. Foreign keys to the professor and then join it back to the section, right? So if I could answer in one way, I should eliminate one of them, okay? Certainly I don't want to eliminate has, right? Because then that would eliminate the relationship between the grade and which section did they get it on, right? So instead, I'm going to remove the assigns because I already can answer that question by following the left-hand side, right? So removing that, we're going to update the class diagram in a minute. What about over here? Being able, so the idea would be to follow all the paths, right? Again, depending on the question you want to answer. It might be that there are some questions that you don't have a question for, right? And so the same diagram would not be redundant, right? If the question was not there, what grade does a professor assign in a particular section? If that's not a question, then that diagram not necessarily is redundant, okay? And that question came from the requirements. So it is the requirements that make something redundant, not the class diagram that you draw. So you can't be asked, hey, is this class diagram, does it have any redundancy? Well, if you don't tell me what kind of question you want to be able to answer, I can't tell you whether it's redundant or not, right? It's under the particular use cases and particular requirements gathering that originally was taken earlier, that then I can answer you in that context whether something is redundant or not, right? So anyway, here we want to be able to answer. So you should follow all the paths and see if you can answer the queries in any different other way by exhaustively going through all the paths. So this one also, whenever you have a cycle like this, like we had over here, whenever you have a cycle, right, certainly should worry you and says, ooh, is there redundancy here, right? Can I traverse this one way or the other? Here, it might, at first look like there might be a redundancy that I could answer questions about students enrolled in different departments and the courses and whatnot. And so I could certainly navigate following the green paths or the red path to see relationship between the department and the students. But notice that if I remove the majors in, right, because I would say, well, I could always answer which courses are being taught in the department, which sections for a given department. Notice that I can also I cannot answer over here which student is in a particular department, right? It is lost in this many-to-many in the grade assignment, right? Because it's a many-to-many, it doesn't capture which student is in what particular department, right? So I do need to keep that majors in because there's nowhere else in my capturing that information, right? I would have to maybe capture somewhere else, maybe in the grade assignment somehow, right? that is pointing to the department. Perhaps that might be an alternative, right? So even though this is a cycle, right, I should not remove it because then I would not be able to answer one of the queries, right, of what student is in a particular department. So yeah, not all cycles are necessarily redundant. Okay, so be careful. Again, it depends the question that you're making, that you're asking. Yeah, so check all the relationships for redundancy, following exhaustive search through each one of the paths, and some of them are not redundant. Okay, so now including removing the assigns, right? The connection between grade assignment and professor, and also the need for enrollments. We remove that, and now it's all in the grade assignment. So this is looking a little bit. We've pruned some of these redundant and some inadequate relationships, and we end up with something like this. Now, right, so one of the things that our original algorithm did not deal with, right, were many-to-many relationships, right, where you would have weak on both sides, right? And so, for instance, let's consider a little change in the requirement from this one-to-many, where you have just one department to many students. What if we would allow students to be enrolled in multiple departments, right? Where we have many students enrolled in many departments and a department having many students, right? So you have something like this, right? Where a student might eventually major in multiple, having multiple majors, or maybe a major and a minor or something like that, right? So in that case, the typical way to reify and create and actually implement this in a relational data model is to put in between a mapping table, right? That would have a many to one to the original two classes that were originally in relationship, right? And the way you would implement this in a relational database is that each one of these would be converted. Each one of these stars would be converted, implemented as a foreign key to their original primary key that they're referencing, right? So this is a very, very common way to convert weak, right, into two weak-strong relationships, right? To convert this into a mapping table. Right, so eventually what you end up is you remove all many-to-manys, right, and convert them into multiple one-to-many relationships. So here's another example where you might have, so in the original case, you had one department having many students, right? And in that case, one student had one major GPA, but what if that student could be enrolled in multiple departments, right? So now it becomes a problem because it could be that you have a major GPA per department, right? You might have a different scoring for each one of the courses that you're taking for that particular department. So how would you capture this? Notice that the way it's captured over here, there's no way for us to say that this GPA is for a particular department, right? Over here, it was implied, right? Since you were only allowed to be in one single department, then your major GPA was obviously for that one department. But what if you have multiples? This does not capture that information, right? We need to somehow bring that GPA, right, and implement the fact that it participates in a three-way relationship, right? It's the student, the department, and the GPA, right, along there. So we need to bring it into into this node over here and say, and then reify it, right? Reify it and actually convert it into a more concrete implementation that has pointers, right, and references to each one of these additional classes. Yes? Now, Now it might be that some students, it might be undecided students, right? They might be not enrolled in any department, right? So we would like to be able to capture or enforce the fact that if you're not enrolled, there is no GPA, right? There shouldn't be any record for a GPA if you're not enrolled in any department. Only if you are enrolled, then we are keeping track of the statistics about you, right? So somehow, so the department now becomes kind of optional, right? A 0 or 1 over here, right? Where if you're not enrolled in a department, then there's 0. There's no record for that department for you, right? And so there shouldn't be a major GPA for you either. So we would like to be able to enforce that. Here, notice that this does not enforce it. Right? This one says that if you don't have a department, if you don't have a department, you could have a GPA. Nothing is stopping you, right? So this does not capture that rule, that business rule that we might add there. That is that if there is no department, there shouldn't be a GPA associated. So what we could do is that we could bring it into the relationship and bring the 0-1, the optional. We could bring that over as part of the student with major relationship, meaning that this says that the record here is optional, right? The whole record is optional, and that if you are enrolled, if there is a record, then that means that there is a reference to a department and there's a reference to a GPA. But if there is no record, there is no reference to a department, and there is no record for GPA. So it's either all or nothing. Okay, so you could also model it that way. All right, so let's look at the permits. So on the permit side, notice that what we're capturing for the permit is that it's an optional permit, right? It says, and if there is a permit, then we are capturing either a single license plate and perhaps a reference to a car model, right? Yes.
Could you go to slides? Could you go back to slide? One more. Yeah. Now there could be a relation between department and major GPA as one and that could also solve the problem, right?
Right. No. But it's the database is not stopping me from doing something that is inconsistent, right? Like for instance, I don't have a department record, but I have a record for GPA, right?
Yeah, that
which
could be fixed by another relation between the department and major GPA as 1 and 1.
Right. Exactly. So this is what it's trying to do here, right? That we are capturing that three-way relationship, right? We're saying that it's the whole record is either or, right? So so this one says what department you're in and which GPA you're in, and this actually allows you to have multiple GPAs for multiple departments, right? And it could be a 0 or 1 for each one of them. Yep. Where were we? Right, the permit. I lost my train of thought. What was I gonna say? Right, so the student has could have a permit or not, and if there is a permit, then there will also be capturing the license plate, and also we'll have a reference to the car model, where the car model presumably is a list of all the car models that are available, right? And we have a pointer to the car model for that particular permit. And if there is no permit, we don't have any of that, right? For that particular student. And then, okay, we want to capture the date of expiration. Okay, so we want to issue the permit to at most one student, but only some permits will be issued to students. Students can have at most one permit, but some students will have no permit. Okay, we did that. Each permit can be issued to at most one student, but only some permits will be issued to, but some. Okay, I think what they're trying to capture here is that some permits are for faculty and some permits are for students. I think, and perhaps permits for students expire, but permits for faculty don't expire. So here we're capturing additional information about expiration dates, and so notice that we have an optional record that depending on perhaps on your role, whether you're faculty or student, you might have an expiration date, but maybe you don't have an expiration date, right? So if you're a student, you have a record. Otherwise, you don't. Expire depends on receives. Okay, so we're explicitly distinguishing permits that are for students, right? So if it is for students, then we create a record that has an expiration date. If so, presumably this permit also has a link to a professor, perhaps, right, or has a link to a faculty that doesn't have a record for expiration. But if you're a student, then there is an additional record that additionally captures the fact that it will expire on a particular date. Okay, I think this would have been a little more clear if I had a reference maybe to a faculty or professor, right, that didn't necessarily go through this student permit that has an expiration date, right? Yes, I'll add an additional link here to a faculty. Reify, weak to remove, okay, and then or convert them into multi-way relationships. Strong. Now this strong over here, for instance, between permit and student, which is a one-to-one relationship. One legitimate question that you might ask, maybe not for this example, but one legitimate question is that because I have one student and one student has just one permit, why even bother and splitting it into separate classes? Right? Couldn't just permit be just an attribute of the student? Right? Couldn't that just bring it over? Right? Why even bother having it there? Especially if, for instance, what about this license plate in the permit? Also one-to-one, right? Why even bother having a separate record, right, in a separate table? Why don't we just bring that license plate as part of the permit? Right? You could just bring it in, just make it an attribute. Why even bother having a separate record for that, right? So certainly that's part of the step of deciding whether some of the nouns that you at first might have thought that they should have been classes, you start realizing that there's no need to model it that further, right? It could just be an attribute of a different class. Yes?
But if you're going by the previous slide that said both students and faculty get it, then that would mean you're going to end up with license plate car model twice, which means you could end up with a whole bunch of screwbally stuff.
Yes, right. So in this case, I believe we merged. What do we do here? We merged
it into student.
We did, right? We merged permit into student. And left the license plate alone. We could have done the other way around. We could have just merged the license plate into the permit. And again, it depends on what kind of model do we want for the license plate. It might be that the only thing we're capturing perhaps is just the number of the license plate, right? But if you go further than that and start, capture the whether it's from what state it is, right? Maybe the color. Maybe if it's for handicapped. So if you start expanding all the fields that you need to capture, then certainly an attribute would not be enough, right? Then you decide, okay, well no, this has to be its own class, right, with its own fields, its own records and whatnot, right? Again, it depends on what kind of granularity do you want to capture the real phenomena. So that's this part of that the final steps of just revisiting your class diagram and asking yourself whether a class is worth the data is worth its own class. If you're modeling the professor, right now it has a whole class to record a professor, right? And it might be that you only want the professor's username, and that's enough for modeling our little university. Then why even bother having a whole class for a professor? It might be that professor is just an attribute of some of the enrollment or the section, right? If you need to model further, first name, last name, whether they're an employee, maybe they have different roles in the faculty and whatnot, then obviously a whole class might be needed for that, right? Again, it depends on the granularity of your data model. So minutia on the license plate. How much do you want to model for the license plate? What kind of granularity? And revisit your data model on how much you want to capture about the departments, the professors, and whatnot. Okay. So to transform classes into attributes, there might be several classes that you might be considering that they don't deserve the status of a class, right? That they'd be enough to change them into attributes. And what you would do is, that class might have associations, right? Might have different associations. So you need to replace those associations, right? You need to, for every one that class was associated, you'll need to add attributes to all the classes to which that original class was associated with, right? If for instance, the example that we're giving here is, for instance, the grade year, right? The grade or the year, or the car model, the license plate, the professor, right? Depending on the granularity, they can be just plain all attributes. So, for instance, the year. Notice that the year is related to two things. It's related to the section, right? The year that it was being offered, and also when the student is going to graduate. Right here, presumably we have an enumerator data type, right, of all the listing of all the years possible, perhaps to drive like a drop down, right, all the years that you can select from a drop down. But this can certainly be modeled differently, and just remove this and just move in the year into the section as an attribute, or as an attribute in the student and the graduation year, right? Same thing for the license plate and the car model. We can just move this over into the permit, right, and just absorb them and merge them into the permit. And so if we move the grade into the enrollment, and we move the professor into the section, right, just by the username of the professor, if that's all we want to know about the professor, those certainly can be merged. And the same thing we can do with the license plate and the car model into the permit. Okay, so after doing all that, we actually end up with our original class diagram that we had begun early on, right? Obviously, we knew where we were going, and we made all these transformations with the idea that we would end up with our original class diagram. Okay, you can add additional attributes. Some attributes were implied. Right? It could be that you interview folks, right, and nowhere did anybody ever mention that users need a username and password. Right? Nobody ever mentioned that, or that people have first name and last names. Right? This was all obvious. Right? These were all implied attributes that were never actually specified. Right? So you might have to go back to your data model and obviously revise it to capture certain attributes that were just assumed, right, or were obvious, that were never mentioned in there. Okay, like maybe the department name was never actually mentioned, the course title was never actually mentioned in the original requirements. Some attributes might be multi-valued. Okay, it could be that instead of just one professor teaching a particular section, there might be multiple professors that teach the same section, right? So it could be that, again, it could be a separate class, or it could be an array, right, of these in a multi-valued attribute. Okay, So if you want to capture multiple professors teaching multiple sections, you can convert it into many-to-many, and then obviously we'll need to reify that. Or if we decide that the professor is just going to be a string, right, the username, then instead of a single value for the professor, it could become a multi-value, right? It could become an array of professors, right? Where that array is holding all the usernames of all the professors that are teaching that particular section. Yes? Right? So they become lists, linked lists, or arrays, and reify it to be able to reify a many-to-many relationship. Aggregation, we took a look at that. That allows us to keep track of relationships between multiple instances. And we keep track of the life cycle of different objects. You know that if you have an order, if you're ordering an engine, if you remove the order, not necessarily the engine disappears, right? The engine is still there, right? And it's still in our database. Just the order is gone, right? But we don't remove the record of the original engine that was ordered. Or if we have references, a car has a reference of what engine is being used, but we remove the reference to the car, the engine is still there, right? Or if we remove the reference to the wheels are still there. But if you have compositions and you kill a person, the hands and legs disappear. I don't like that example.
Cut that out of the recording.
I think I'll recall. Yes. Generalizations and inheritance. We talked about this, right? Where you might have different special cases of people, such as students and professors, having special data, but might have different common pieces of data that are captured in a base superclass, like a person. You might have here's another one that would be implemented, such as this, right? You might have a person ID, and that person ID. Notice that it's a primary key that is holding the values of all the attributes that are in common with all the other tables, right? But notice that the professor table and the student table. Notice that they keep track of the additional special fields for that particular class. Yes, but notice that the way this is implemented is that they have their primary keys, right, are also foreign keys. You see that, right? So this is one way that an object-oriented hierarchical inheritance hierarchy, right, could be implemented in a flat, right, relational data model, right? In a relational, even though relational databases don't support object-oriented hierarchies, right? You can nevertheless, right, come up with a schema that can be used to implement a inheritance, right? Using this kind of mechanism. I'll demonstrate next week how we can actually implement this. Actually, part of one of the assignments a little later, right? That asks you to create schemas that implement inheritance. And it's actually not just one. There's several alternative ways of implementing inheritance, right? Using a relational schema. I'll give you an example. Cool. So here we have a student that can also be so here you have TAs that are students, right? All TAs are students, so you have students by themselves, right, that are not TAs. So that's a concrete class. It's not an abstract class. So there are instances of students that are not TAs, but then all TAs are also students, and they might have other attributes such as office hours and whatnot, right? So to implement this inheritance relationship, we would need a table that captures just a student record, right? And then we would have another table that captures the office array for the TA, but then the record for the TA, if you want to ask information about the TA, all the information about the TA will be spread over two classes, right? Over two records. So if you want to recreate the TA, you're going to need to join, right, and fields from the TA table plus some fields from the student table, right? So they're spread over several of those. And it makes no sense that one would exist without the other, right? It makes no sense that I would have a record for TA but not have an equivalent record for a student, right, for that TA, right? So that if, for instance, I remove the student that is represented by that TA, right, the deletion of that record of that student, which should cascade down to the record for the TA, right? It makes no sense to have a record for the TA but not an equivalent record for the student. Now, to implement that, let me show you. This is the implementation, which we'll start looking at next week. We create a table for the student that has a primary key for the ID and obviously the name of the student. And then you have a table for the TA that is implementing the subclass, right? Where notice that the primary key for the TA is also, right, a foreign key referencing the primary key of the student, right? And notice that we have a cascade, a delete cascade, right? Meaning that if a related student record gets removed, also the TA record gets removed because it makes no sense to have one without the other, right? They're just one of the same thing, right? And this is just more reification of the other tables, and we'll take a look at that next week. All right? Awesome.
Trying to figure out how you're going to get through 20 slides in